Good morning. Welcome back to the OHSU Effect Inside Health and Science. And I'm honored to be joined by Dr. Albert Starr and Dr. Sanjeev Kaul this morning, both very experienced in their field of cardiovascular medicine. And we want to continue our conversation about heart health, specifically what's new in valve surgery. OHSU is one of a few centers in the country qualified to implant a new type of heart valve called the Melody valve, and this does not require any open heart surgery. Dr. Starr, do you want to talk about this new valve?
Oh, yes, I'd be happy to. The Melody valve is a valve developed for use in the pulmonary position and primarily, because there are a large number of patients who had disease of the pulmonary valve that we were able to repair during infancy or childhood, but the valves were not perfect in their repair. They didn't grow properly, and they became insufficient. That is, they couldn't close. They didn't close completely, and so we needed to have a device that we could implant that would substitute for the pulmonary valve, and it was possible to do that by mounting a compressed valve onto a catheter and then introducing the catheter into the heart through a peripheral vein and getting it into the right position using fluoroscopy to control where it was. And then by blowing up a balloon which deploys the catheter inside of a little stent, then it was possible to replace the pulmonary valve without surgery. The valve was called the Melody valve as a product, but it has nothing to do with music or anything like that. It has to do with a device that replaces the pulmonary valve. It's a really neat way of doing it, and the risk is relatively small. It's not an operation, and these valves have functioned beautifully.
Yeah, it's amazing what they can do without surgery.
Right.
Yeah. So who qualifies for these valves?
Well, the most important segment of the population would be the ones who had previous pulmonary valve surgery. A lot. One of the first operations we did when open heart surgery started was called pulmonary valvotomy, where we operated on the children with open heart surgery, opened the pulmonary artery, and then separated the stuck leaflets from each other so they would open and close properly. But when these leaflets do not develop well, then later on in life they may need a pulmonary valve replacement, and this is a way of doing it without another operation.
Do you think these new types of valves will make open heart surgery obsolete?
No, they won't make open heart surgery obsolete, but it's really nice not to have a second operation after you've had a pulmonary valve operation in childhood.
Now, there's another brand new valve called the sapien valve. It was just approved by the FDA, and OHSU is going to offer this soon. Explain how that one works.
Well, the sapien valve was developed initially in Bordeaux in France about 10 years ago, and finally has reached the point where it's now available in the United States. And it's a great little device. It's like our other tissue valves that we implant surgically, made out of pericardium, but instead of having to sew it in, the pericardial valve is in a stent which is then compressed, so it will go through a small artery, and then this stent can be passed up under fluoroscopic control into the aortic position and then dilated into place. And so it's not a substitute for an aortic valve replacement surgically. It's used primarily for patients in whom the risk of a standard operation is very great.
I see. So you wouldn't want to have surgery on these patients.
So that's where this valve is very useful, at least today. There will be other iterations of the valve as time goes, and then maybe a decade down the road, one could argue, do you do surgery or do a valve? But at this stage, it is meant and indicated only for people who cannot be operated on, which is a large number of people over the age of 75 or so who have thickening of the valve, a lot of calcium in the valve. But along with that, they have other morbidities. Commonly, for example, the way to replace the aortic valve is you go through the aorta, which is the big artery coming out of the heart. But a lot of these patients have calcium in the aorta as a part of the disease process. So if you try to go through the calcium, it becomes very difficult to repair the aorta and so on after that. And there are chances of stroke and so forth. So those are the patients who would benefit from this procedure. Also patients who have lung disease can't go on for surgery. Patients who have chronic kidney disease, a lot of other disease of the arteries, who basically are not surgical candidates because they would really, they may have a 50% chance of surviving an operation. But with this device, the risk is lowered much more in these patients.
Yeah, because what is the prognosis without this valve for them?
Oh, most of the patients who are getting this valve now would be dead within 1 year if they did not have a valve replacement.
From heart failure.
From heart failure, right.
Wow. So a lot of advancements here for people who are already in poor health. It sounds like this valve is going to help them.
There's even more to go because this is just the first stage in what we call hybrid surgery. What we mean by that is that the cardiologist and the cardiac surgeon work closely together, that they don't have to operate through large incisions because they use imaging techniques, one of which was developed by Sanjeev himself, imaging techniques to see what's going on, and they could and valves could be implanted or replaced without a major operation. The next one that to take place will be a mitral valve replacement, and that will be done through the apex of the left ventricle through a very small incision. So the surgeon makes a small incision, is working with the cardiologist. The X-ray is available for guidance, and together the team puts in this mitral artificial valve, and there'll be many steps even beyond that of hybrid surgery, reshaping the left ventricle so that it can pump more effectively.
And when Albert mentions the word hybrid, this has created a new way of collaboration between surgeons and interventional cardiologists, because interventional cardiologists work in the catheterization laboratory. It's all catheters, endoscopy, and all of that stuff, while surgeons work in the operating room. Now at OHSU, we are developing hybrid laboratories. That means you can do both at the same place. And so a surgical team and an interventional team are using all their devices and tools simultaneously to be able to come to a particular result.
That's great.
And that's why we're both here, a heart surgeon and a cardiologist, collaborating together on a radio program.
It makes sense, doesn't it? Well, we want to talk about imaging next with Dr. Sanjeev Kaul and Dr. Albert Starr. And after that, we're going to discuss congenital heart defects. That's next on the OHSU Effect.